Welcome to week 16, Math Accelerated. We are solving multi-step equations, and this is Mrs. Witt. So let's begin by just reviewing some of the terms that are important for us to remember. So first, a variable. Remember that just represents any unknown value. So it can be a letter like X, it can be a picture, it can be a symbol, it doesn't matter, it just stands in for a value that we don't yet know. Like terms, they always are going to share the exact same variable. So we can combine them because they are alike. Like 2x and 4x can be combined, but 2x and 2x squared cannot because they're not the same. A solution is a value for x, a value, let's just say a value for the variable that that makes the statement true. It makes it true. So just kind of a side note, we remember that, let's see, if we solve an x equals some number, then we know we've got one true solution, right? But if we solve and find that the x's go away, like they've canceled out, so to speak, and we've got a true statement like 7 equals 7, then we know that there are many true solutions, because no matter what we put in for x, we're always going to end up with a true statement like 7 equals 7. If we get a statement like 8 equals 5 where it's not true, we know that there are no true solutions, or there are no solutions, because no matter whatever we put in for x, 8 will never equal 5. Okay, so that's kind of a sidebar. That's a side note to help remind you of how many solutions there are. Now finally, we're going to remember what inverse operations are, and we need to remember that they basically undo an operation. So how do we undo addition? We subtract. And we can look back and say that we can undo subtraction by adding. How do we undo a multiply? Well, we will divide. And how do we undo divide? We will multiply. And then how do we undo, for what we know now, very simply, how do we undo an exponent? What we know how to do so far is just find its root. And if we have the root, we know that we can raise it to an exponent. Okay? So those are basically the inverse operations that we have learned so far. So let's recall, what is the order of operations? Well, the order of operations tells us which operation to do. We might want to say first or next. Okay? And remember, what is an operation? Well, that's easy. An operation are things like plus, minus, multiply, divide, or taking something to a power. The operation is what we do to a thing, a number, a variable. Okay? So what we've already learned is that our order of operations starts with G, which stands for, when we're simplifying, we're going to do the grouping symbols first. So grouping symbols, we already know, grouping symbols can be parentheses, they can be brackets, they can be absolute value bars. There's a lot of different things. Anything that groups those together, those are what we're going to tackle first when simplifying. We know next we would try to simplify exponents. And last week we talked a lot about exponents. That's like something raised to the second power or the third power. And then we are going to, the M in GEMS is multiply or divide left to right, right? So we will multiply or divide, and we like to do it left to right. We know that with our properties, sometimes we can move things around, but let's for the sake of right now, just keep on thinking about left and right. And then we know that the last thing we're going to do is we're going to subtract or add. Again, we like to think left to right. We also know that sometimes we can change our grouping and our order because we know the commutative property and the associative property, but it's just a good thing to remember. It's a good way to keep track of it is to do it from left to right. Subtract or add from left to right. And that kind of helps us not make mistakes with positives and negatives. But like I said, we know that we actually can do them. We can skip around a little bit and change our groupings. But if you don't want to make mistakes, you can just start left to right. So I want you to consider for a minute, if we simplify using GEMS, how we might use GEMS when we're using inverse operations. So I'll give you a minute to consider that. Well, when I think about it, if I want to simplify, let's see. If I use GEMS to simplify, and I use all of my inverse operations to solve, then what I'm probably going to want to do is use GEMS backwards when I'm solving, right? So if I'm going to simplify, I'm going to go down. I'm going to start with my groupings and go down. But if I'm going to solve, then I want to start at the bottom and move up. I'm going to do the inverse. Okay? So that means I'm going to first, sometimes you hear it working outside in. But I'm going to just say for right now, we're going to try and isolate. What we want to do is we want to isolate, and we know this from doing one steps. We're going to isolate the variable, a single copy of it, one single copy of the variable on one side of the equal sign. And to do that, we're going to go in the opposite order of GEMS. So let's give that a try. So we know if we were simplifying, we would do GEM, multiply and divide, and subtract and add. So now this time, we're going to think about doing it backwards because we're solving and everything we're doing is inverse operations, right? So let's start with our first one. Let's try, do we have any subtraction or addition? Let me make a note here that this is the inverse to solve. Okay, so yes, I have a plus 7. So the inverse of plus 7 is minus 7, what I do to one side of the equal sign, I have to do to the other. So a positive 7 and a negative 7, those add to 0, right? So those basically go away and I don't see them anymore. I still have a 12x on the left side. My equal sign still lines up. And I have a positive 19 and a negative 7. So I can think 19 minus 7. Well, that's just 12. So I don't have any more subtraction and addition. So I'm going to go on to multiplication and, subtraction or addition. So now I'm going to look for multiplication or division. Well, x is not alone on one side yet because I've got, instead of just one x, I've got 12 x's. So I've got that 12 attached to it by multiplication. And so I want to do the inverse of multiplication, and I'm going to divide by 12. What I do to one side, I have to do to the other side. Now 12 divided by 12 turns into 1, so I no longer have to write that. On the left side, I have x. My equal sign still lines up. 12 divided by 12, we just said was 1, but there's no x over there as a placeholder, so I have to actually write 1. So we've determined by using our inverse operations in the backwards order of gems, that x equals 1. And if we want to check that, we can always just plug it into the original to see. 12 times 1 plus 7 equals 19. Well, 12 times 1. Now we're going to use gems the right way because we're simplifying it. We're not solving it. So multiplication division comes first. Gives me 12 plus 1 equals 19. I'm sorry. That's a 7. There we go. And 12 plus 7 is 19 equals 19. That is a true statement, so I know that this is correct. All right, so let's try again. We're going to use the inverse operations to solve, so we have to do our gems backward. So let's first look for subtraction and addition. Well, it's kind of hard to notice, but what I do notice is that 2 minus x, that is subtraction and addition, how it's kind of stuck together. But I want you to keep in mind, I want you to notice that this is actually a positive 2 out front, okay? We didn't write it because it's the beginning of the statement, but we know that that's positive. So the inverse of a positive 2 is a minus 2. What I do to one side of the equal, I have to do to the other to keep it balanced. Well, my positive 2 and my negative 2, they're simply going to add to 0, so I don't need to write them anymore. So on the left side, I have negative x. My equal sign still lines up. I have 16 minus 2 gives me 14. So I want you to notice that we haven't finished yet. We do not have a single copy of x alone on one side. And that's because what we have is a negative x, which is the same thing as negative 1 times x, okay? So what I have now, I've done my subtraction and addition. The only thing left is multiplication and division. I want to get rid of that negative 1 that's multiplied to x. So I'm going to divide by negative 1 on both sides. Well, that simply reduces to positive 1, which leaves me with a single copy of x. My equal sign is still there, but now I have a positive 14 divided by negative 1 gives me negative 14. One simple single answer. And I can again plug that in if I want to check it. Let's move on. Now here, what I notice is different is that I have x's on, let's see, I have an x over here, but then I also have some x's over here. And we know that we want to get x's alone on one side of the equal sign. So the first thing I'm going to do is I'm going to move all of my x's to the other side. Okay, so I'm going to get all of my x's together. So to do that, I have to get rid of the ones on the right side. I'm going to try and move them to the left side. So when I do that, how do I undo that positive 2x? Well, I'm going to do a negative 2x. And what I do to this side, I have to do to that side. So now I've got x minus 2x. Okay, well that gives me a negative 1x or a negative x. I've still got my plus 4. I still have my equal. that turned to 0. I don't need to write it anymore. And I still have minus 19. All right. So now, I have my x's on one side. I don't have them alone or a single copy yet. So I'm going to look back at my gems and I'm going to do my inverse order. What can I subtract and add first? Well, right now I see a plus 4. So I'm going to subtract 4. What I do to one side of the equal sign, I have to do to the other to maintain balance. So I still have my negative 1x, or my negative x. Positive 4 and negative 4, they add to 0, so I don't need to write them anymore. Negative 19 minus 4, a negative, same signs add and keep, different signs subtract. Keep the sign of the larger number, then you'll be exact. Well, I've got the same sign, so I'm going to add and keep the sign. Now I'm so close to being done. But what I notice is that what is stuck to my x? I've finished with my subtraction and addition, and I can move on to my multiplication and division. Right now, I have a negative 1 multiplied to my x, and I need to get rid of it. So let's do the inverse operation, which is divide by negative 1. Divide by negative 1. All right, negative 1 and negative 1, that's going to turn into a positive 1, which essentially gets rid of it and leaves me with that single positive copy of x like I want. My equal sign is there. Negative 23 divided by negative 1 is simply positive 23. And again, I can plug that into my original if I'd like to check and see if that's correct, but I'm pretty confident right now. All right, so the next one, what we notice is that we have, you might see it written different ways. You might see it written like x over 4 plus 6 equals 10, or you might see it as 1/4 of x plus 6 equals 10. These are all equivalent statements, but let's just look at this right now and say, well, we've got x, all of our x's are on one side, so let's go ahead and hit straight to our inverse order of gems. We're going to start with subtraction and addition. Well, I see that the subtraction and addition I have is this plus 6. So I want to go ahead and minus 6 from both sides to undo that. So that adds up to 0, goes away. I still have x divided by 4 on the left side. And on the right side, I have 4. Okay, so I've done any addition and subtraction that's stuck to x. And now the only thing left is that x is divided by 4, which is good because that's the next thing on my list to check for is multiplication and division. So to get rid of divided by 4, I'm going to multiply both sides by 4. So if I divide something by 4 and multiply by 4, it basically undoes it. On the left side, I still have x. I still have an equal sign. And on the right side, I have positive 4 times positive 4, which gives me 16. And again, if I'm unsure of my answer or if my teacher tells me to, I can plug that back into the original, and that will tell me for sure if my answer is correct. So now I'm going to give you an opportunity to work through some of these on your own. So I'm going to have you hit pause on this video, and after you have worked them out, you can go ahead and check your answers. All right, so hopefully you got the same answers I did. You worked your way through it. You noticed on this one that there was an x on both sides, and you had to move that very first. And hopefully you also remembered that instead of just focusing on gems, you were doing the inverse, so you were going the other way. All right, so let's recap. To solve for x, we want to get a single copy, a single positive copy even, a single positive copy of x on one side of the equal sign. And that's when we're solving equations. You know, it could be an inequality if we were solving inequalities. And to do that, we are going to use inverse operations to isolate the variable. Or I'm just going to call it x right now, but it could be any variable. Now, instead of gems, what we're going to do is we're going to use, basically, we're going to do the inverse order of operations. So we're going to kind of work backwards. So instead of doing grouping, then exponents, then multiply or divide left to right, and add, subtract left to right, when we're solving, we're basically going to go to solve. We use the inverse. So we're going to take all of that and go the other direction first, okay? So we'll start with addition and subtraction, then we do multiplication, division. If there are any exponents, we'll do that next. And you guys worked on that, why don't I give you a quick, let's do an example with an exponent, since we do know how to solve using exponents. All right, so we're going to be looking at our gems working backwards. Okay, we're going to go backwards with our gems. So in this example, the first thing I'm going to look at is my subtraction or addition. That's poorly written. So subtraction or addition. Well, here I notice that I've got a plus 7. So I can subtract 7 from both sides. What I do to one side, I have to do to the other. Well, those 7's go away, and it leaves me with 2x squared equals 32. Okay, so I've done my subtraction and addition. Let's look for multiplication and division. I wrote that so badly. Okay, so multiplication and division. Well, I see that I have a 2 multiplied to my x squared, and I can get rid of that. So let's divide both sides by 2. Well, 2 divided by 2, that turns into 1, so it basically goes away. It leaves me with an x squared equals 16. All right. Now what we would look for, because we're still going in our reverse or inverse order, is exponents. And we have learned to solve by taking the root. So if I take the square root of x squared, and then I take the square root of 16, well, this cancels each other out. And on the left side, I just have x. And what is the square root of 16? Well, what times itself gives me 16? Well, I know that it could be positive 4 or negative 4. So remember, sometimes, or a lot of times when we've got our square root there, we're going to have two answers, positive and negative. And let's just check that to be sure. Okay, so let's try positive 4. So 2 times 4 squared plus 7 equals 39. Okay, well now we're going to have to do gems in the correct order. Multiply and divide, left to right. Subtract and add, left to right. Because we're simplifying. So there's no groupings, but there is an exponent. There's 4 squared. So I've still got 2. But instead of 4 squared, I now have times 16, because 4 times 4 is 16, plus 7 equals 39. Now I can multiply and divide left to right. So I've got 2 times 16, well that's 32, plus 7 equals 39. And now I can do my subtraction and addition left to right. 32 plus 7, 39 equals 39. Bada boom, that's true. Now let's try and see if it is true for negative 4 as well. So 2 times negative 4 squared plus 7 equals 39. Okay, well, we're going to do that same order. There's no groupings, exponents. Negative 4 times negative 4 is positive 16. So again, I have 2 plus 16, or times 16 plus 7 equals 39. And as we've already seen, we can go through those steps and find that that indeed indeed does give us a true statement. So we can see here that it's no different when we have an exponent. We just have to do it at the right time and remember to use the correct root. All right, you have plenty of information to do your choice board for the week and your activities. Good luck.